cos ratio, and tangent ratio. Now, why we call it as ratio? Like now, when you talk about the definition of these things, if you write on sine, cos, and tan, it is irrelevant. There is no meaning to these values. Now, sine, for example, when you write on log, log is just an operator. Okay, so it operates on some number with certain base. So same way, it's like sine, cos, and tan. These are basically the operators which operate on certain angle. So like sine theta, cos theta, and tan theta. You can obviously use any variable you want. You can use like sine x, cosine x, so cos x, and tan x. Actually, the full form of this is a sine ratio, like SINE. This is cosine, and this is like tangent. When you do the advanced math, that is like either add math or HL level math, you get three other ratios that you will define later on. Probably when I'm covering up the part will be like sec ratio, which is sec theta, cosec theta, and cot theta. So these three ratios are the brand new ratio that we define, which sec theta is actually the reciprocal of cosine. So, okay, so this is reciprocal of cos theta. So whatever is this ratio that you get, if you reciprocate it, you get sec. If you reciprocate sine, that's your cosec. And if you reciprocate cot, you get, reciprocate tan, you get cot theta. Okay, so I know this might sound like a little kind of strange at this stage, but we first let's talk about these three ratios. So sine, cos, and tan. So when I define, let's say, sine theta, cosine theta, and tan theta, I'm talking about the context of a right angle triangle. So when you talk about the right angle triangle, now first thing is that you have to have an angle for reference, for which like I'm taking theta here. Now, in this case, I got this as the adjacent side, this is opposite side, and this is the hypotenuse. So when you define the ratios, actually you have to be very careful while you take the which side is adjacent side, which side is opposite side, and which side is at hypotenuse. And obviously hypotenuse, is the largest side in a right angle triangle opposite to 90 degree. That's very easy to crack. Opposite is obviously the straight opposite angle to the opposite side to the angle, and adjacent is the one which is just next to the angle. So the first thing, I'm assuming that this definition of adjacent and opposite side is pretty clear. And now we define the ratio. Okay, so we define the ratio of this is sine theta is basically defined as, so we got a rule which we use as a shortcut, Sohcah Toa. So Sohcah Toa is a rule that we use. So sine of any angle is actually opposite over hypotenuse. So that's what it means, that O over H. Cos is adjacent over hypotenuse. So adjacent over hypotenuse. And tan is opposite over adjacent. So tan is opposite over adjacent. So opposite over adjacent is tan. So now, for example, if I take this as, let's say, 3, 4, this length is 3 and 4, and here by Pythagoras, we're going to get 5. Now, what is the ratio value? Okay, so what is the ratio value? So when you find the ratio value, you will get sine is opposite. So let's see, if I take this as the theta, my opposite angle is 4. So it is going to be 4 over hypotenuse is 5. So 4 over 5. So cosine of this is cos theta is going to be adjacent of the angle. So adjacent side of the angle is this side. So this is the adjacent side. So that length is 3 and hypotenuse is 5. And the last one is the tan ratio. So tan is basically, so tan theta is opposite, which is 4 over 3, which opposite is this and adjacent is this. So this is how you define the ratios. Like how do you, so logically you can say, what is the importance of this? Like for me, like at this stage, if I write a ratio, it makes no sense. It makes no relevance. But if you look at this now, indirectly, what you're trying to do is, if I link up with the same problem with a context where, okay, let's say there is a tree, okay, and which is now making which is a height of, let's say 4 meters from the ground, and there is an observer who is standing here and trying to see from, let's say, his camera the top of this tree where a bird is sitting. Now assume that this height is 4. So what we get is we can find out at what angle should this person incline his camera so that he can see that bird. So here what I'm going to do is, let's say if I know this ratio, okay, that okay, I have got vertically opposite side to the angle and adjacent. So which ratio should I use? So let's say Sohcah. Let's talk about Sohcah and Toa. So it's very interesting. Now what I can do it with this like simple problem and the trig combination. Now see, if I know one of these two sides, like one of these two things, if I know, I can find out the third one automatically. So if I know sine of the angle, if I know the hypotenuse, you can find the opposite side. If I know any of these two, I can find the third one. So let's just first take an example where you have been given a dimension and you want to find out a missing angle. So in this case, my opposite side is given and adjacent side is given. So most appropriate ratio that I can use is TOA, tan ratio. And it is simple. So tan of that angle is opposite, which is opposite 4/3. So what I get is, now I can find the angle. Now the procedure is that if I have got an angle, let's say if I have got a ratio, let's say tan theta is a value which is here. My theta, I'm going to write as this is one step which carries a step mark, is tan inverse. So tan inverse means, okay, from this given ratio, 4/5, 4/3, you find out what's the angle. Okay, and how do you do that? So if I know that, okay, tan theta is 4/5, so theta is going to be tan inverse of 4/3. If similarly, if I got, let's say, sine theta out of this context, if I have got sine theta is, let's say, 1/2, my theta is going to be sine inverse of half. So I'm just going to quickly show it to you how to do the same thing, this part on calculator. Now, how do you find out exact value of the angle? Okay, so now what we got is in the previous part is, let's say I had got the ratio, the tan theta is 4/3 and theta is going to be tan inverse of 4/3. So now how do I find this out on calculator? So I'm just going to quickly give the brief about how to do the calculations on this. So now if you notice, whether it is Casio 991 ES series or GDC, you will notice that these are the keys that are very helpful. And if you look at on the top of each key, these are the little small letters in yellow. And that's where that, in case if I've got an angle and I want to find out the sine ratio. Now, for example, if I wanted to find out sine of 30 degrees, okay, sine of 30 degrees half. Okay, and at the same time, you got to see whether your calculator in which mode. Is it in degree mode or radian mode? Here it is in degree mode. You can see that on whether it is GDC or the normal scientific, you will see like a D or slash or R option on scientific calculator as well. So make sure your calc is in degree mode if you're doing the calculations in degree mode. Radian is something that you'll be more clearer when you do later part of the trigonometry. So I'm just right now I'm keeping the calculator in degree mode. My objective is to understand, let's say, how do you find out, let's say cos of 60, let's say cos of 60 is half. Now, in this case, guys, what we do is if you press shift and tan, let's say if you press shift button, now shift tan, you get the tan inverse, and tan inverse of what? Tan inverse of 4/3. So what it helps us is to find out the angle. See, if you consider the previous example of the tree and the person, this angle actually is 53.13. So this is how the trigo can be helpful. You don't need to climb on the tree to measure the angle. And also it is very, very interesting because it has got the ratio values. So you can link up the different things like the side lengths and all. I'll just take a simple example. If you're like sine 60, now let's say sine 30. So sine 30 is actually, so sine 30 is half. If I show it to you here, sine 30 which you calculated is actually half. Now what does it mean? Now if you look at sine 30 is half, what does it mean is, if this is 30, so whatever is this, because this is a ratio. If I take like, okay, let's say this length is 10, this is 20. So if I take this is opposite length, which is 10, my hypotenuse has to be 20. If I take this is 100, this has to be 200. So how we manipulate the ratios and the angles, this is a very, very interesting part of the trigonometry. that, okay, why do we need trigo? That's the first question. So it tells you that ratios that we use give the proportion of the sides also of any given geometrical shape. So I hope this is like a basic trigonometry. The Sohcah Toa part is clear. Now we're going to take some more examples on this of the involvement that how do we calculate angle and ratios and so on. Okay, so now here's a question in that I'm going to use the different ratios to find out different lengths and angles. Now, first case is if I can take the diagram names here, if I can take the diagram as this is A, this is B, this is C and D. It's a composite shape. Let's say this is a part of tessellation pattern. And what has been asked is that this has been given to you as side 3, the length has been given as 3, and this hypotenuse has been given as 5. Our first task is to solve the puzzle for y. What's the value of y and what's the value of x? So obviously to get the value of x, what we get is the simple Pythagoras theorem. So let's say x square plus 3 square equals to 5 square. So you get x square is 16, so x is 4. So I get straight away 4. But now to get the value of y, which is one of the angle, I got to use a given ratio. Now, in case if I want to use the opposite and hypotenuse, I can use the out of these three, Sohcah Toa, I can use opposite and hypotenuse is given, and you want to find the angle. So what you can do is you can use the angle. So let's say sine of the y degrees is equals to the opposite side, which is 3, and hypotenuse, which is 5. So y is going to be sine inverse of 3 over 5. And if I can, sine inverse of 3 over 5 is 36.86 when you find on calculator. So this angle, actually, the first puzzle that I solved is 36.86 angle. Now you got this as 4. Our next objective here is little different. Now our objective is actually, I have been given, let's say 4 in the side, the opposite side, and I have been asked the adjacent side. And here, very interesting part is I have been given one of the angle. So how do we do this problem? Now in this case, you got to see what all has been given. So I have been given an angle, I have been given opposite side, and what are they asking? The adjacent side. So if I look at the simple trigonometric ratio, here it is tan of the 50 degrees. If I find out it is opposite, which is 4, or adjacent, which is z. And what I can do is I can use calculator to find out the missing values. So if I make z the subject, it is 4 over tan 50. And if I can find out this using calculator, so this answer basically comes to 3.35. So this is the answer for z, which is 3.35. Now, another puzzle that I got now next to solve is, okay, I got come to the shape C, which is, I have to find out the missing t value, which is the length of hypotenuse. Now, by the time I come here, and now I have got something very interesting. I have got already the opposite side to the 40-degree angle. So opposite side to 40-degree angle for me is 3.35, and I have to find out hypotenuse. Okay, because here is the right angle, this is a right angle. So I can use, okay, now out of these three ratios, I can use opposite has been given, and I want to find out hypotenuse. So I can, opposite has been given, angle has been given, and I wanted to find out this. So you can use that. So sine of 40 degree equals to the opposite length is 3.35 over the hypotenuse length, which is t. So t from here, if I make the subject and cross multiply, it is 3.35 over sine 40 degrees. So t equals to 3.35 over sine 40. If you can find on calculator. So if you find this answer on calculator, it comes to t as 5.21. So this is till here, now 5.21. Now, when we go into the next last puzzle, which is D here, I have to, let's say, find out this opposite side. So in this case, it is not linked up with the previous shape. So what I have to do is I have to use a ratio that can give me the answer. Let's say I don't want this X. Let's say here I want Y. Now this is, let's say Y length is this. So if I wanted to find out y, the smart move will be, okay, I have the angle, so I can find cos ratio using my calculator. I got the hypotenuse and I got to find out the adjacent side. So you got to use cos. So cos of 60 is y adjacent length over hypotenuse, which is 7. So y is 7 times cos 60. So if you find that on calculator, so this comes to 3.5. So this is about the zero level trigonometry and the basic concepts linked with it. So we'll take some more problems.